Hello friends, welcome to our YouTube channel. Transformer is a device which is used to increase or decrease the voltage of an alternating current. Before I go into the detail of the principle and working of a transformer, let me explain why we need to increase the voltage. We know that the power of transmission is the product of voltage and current. That means the current is equal to power upon voltage. During the process of transferring the current from the power station to the consumer, we maintain the power at a constant level. Assuming that the power is a constant, therefore the current is inversely proportional to the voltage. That means if I transfer the current at a low voltage, there will be more current in the transmitting line, and more current in the transmitting line results into more production of heat according to Joule's heating. H represents the amount of heat produced by the transmitting lines. I is the current, R is the resistance, T is the time. So as the current increases, there will be more production of heat by the transmitting lines, and that means there will be more loss of current due to heating. So we need to minimize that loss of current due to heating, and in order to do that, we should minimize the amount of current in the transmitting line. That means it should be done at a high voltage. High voltage will ensure that there is less amount of current in the transmitting line, and therefore there will be less production of heat, and therefore we can minimize the loss of current due to heating. And that is the purpose of a step-up transformer. A step-up transformer will increase the voltage to a certain level. So you can see a step-up transformer has two different types of coils. One is called the primary coil, another is called the secondary coil. So the input voltage is given to the primary coil and the output voltage is taken from the secondary coil. Now, how many times I need to increase the voltage? It depends on how long the current has to travel. If the current has to travel a long distance, that means we need to increase the voltage many times, maybe 5 times, 10 times, even 20 times. It depends on how long the current has to travel, and accordingly I have to increase the number of turns in the secondary coil with respect to the primary coil. For example, if the input voltage is 220 volt and I want to increase it up to 1100 volt, that means I need the transformation to be done 5 times. So in that ratio, I need to keep the number of turns of the primary coil to the number of turns of the secondary coil. You can see I have made here 5 number of turns, and here I have made 25 number of turns. So the ratio is 1:5, and exactly that is the ratio in which I increase the voltage from 220 to 1100 volt. So you can check the configurations here. The primary voltage is 220, the secondary voltage is 1100. But at the same time, what happens? The decrease in the current will also decrease by the same ratio. So the voltage is increased by 5 times, number of turns are increased by 5 times, but at the same time the current will be reduced by 5 times. So you can check the configurations which I have written over here. Now this is called step-up transformer, and you will see a step-up transformer near to a power station. As soon as the current is developed, then it is stepped up to a certain level, and then this current will go to a long distance before it is consumed by a consumer. But one more thing we need to understand, that this high voltage, say 1100, maybe 2200, this high voltage is not good for the consumer. It is not a safe voltage. So what we need to do, we need to reduce the voltage to a safe limit, and that is done by a step down transformer. So you will see a step down transformer very close to your house. Maybe in your colony there are 200 families which are supported by one step down transformer. And what is the difference we use in a step down transformer? In a step down transformer, the number of turns of the primary coil is more than the number of turns of the secondary coil. So basically what we are doing by using the concept of mutual induction, we are either increasing the voltage by using a step up transformer or decreasing the voltage by using a step down transformer. And in this case you can see the number of turns are also in the same ratio, that is 5:1, which is same as the ratio in which I want to reduce the voltage and bring it to a safe limit. But you can also notice one more thing, that the current which was 2 ampere has now again increased to 10 ampere. So you can check the configuration of a step down transformer. The primary voltage is 1100 volt, which is not safe to use. So I have reduced it to 220 volt, but in the same ratio the current has increased. And how we have done this? By maintaining the ratio between the number of turns of the primary coil to the number of turns of the secondary coil, that is 5:1. So this configuration is for step down transformer. One thing is very interesting, that you see the original configuration, the voltage given to the primary coil of a step up transformer was 220 volt. The same voltage we are receiving as the output voltage of a step down transformer. And you see the current given to the primary coil of a step up transformer, it was 10 ampere, and the same current we are receiving at the output level of the secondary coil of a step down transformer. So the original configuration is restored after the entire process is completed. So only this increase in the voltage and decrease in the voltage is in order to reduce the loss of current in the form of heat. And one more thing I need to explain here, that this K is called the transformation ratio, which is equal to the ratio between the output voltage and input voltage, which is also equal to the ratio between the number of turns in the secondary coil to the number of turns in the primary coil, but it is inversely equal to the current in the primary coil to the current in the secondary coil. So basically we can say, when there is an increase in voltage, there is a decrease in current, and when there is a decrease in voltage, there is an increase in current, so that we can maintain the original configuration but our purpose is solved. This is the way a transformer works. So I hope you have understood the working of a transformer. I will come up with my next video with a new topic. Thank you very much. See you in the next video. Until then, goodbye.